Today we're going to do a quick, well maybe not super quick, but a trig review, starting with this problem here. We have a right triangle. We have to find the exact ratio in simplest form. So if you look at this right triangle, you might notice that this is 3 times 17, and this is 3 times 15. So this is an 8, 15, 17 triangle, so this is 3 times 8, which is 24. And the sine of the angle x is the opposite side, which is 45 over the hypotenuse, which is 51. But if you notice that they both have 3's in them, that would just reduce to 15 over 17. So since all 3 sides are a multiple of 3, you can just take the 3 out of the problem and use the remaining numbers. For example, the cosine of x is adjacent, so we could just write 8 over hypotenuse 17, 8/17, so the tangent would be opposite over the adjacent. And then this next problem just asks you to find the value of x 2 different ways. So you could say, you could set up with your first equation and then take the inverse sine of both sides. So if you take the inverse sine of this side and take the inverse sine of 15/17, you get x is equal to the inverse sine of 15/17. Every calculator works a little different, but on this calculator, you would make sure that you do the 15 divided by the 17, and then you'd really take the inverse sine. So you have to hit this key to get the inverse sine, and then you have to hit equals. And it looks like it's I made a mistake there. I didn't clear it out. Let's clear everything out here. Try again. So 15 divided by 17 equals, and take the inverse sine. There we go. It's just 61.927 roughly. So about 62. I'm going to put a little dot there. About 62 degrees. Doesn't give rounding directions. We're going to round to the whole number. So with method B, we could use, say, the tangent of x is equal to 15 over 8. So to get x, we would just take the inverse tangent of 15 over 8. And let's see if we do better with the calculator this time. I'm going to clear this out. So 15 divided by 8, and now just inverse tangent. 61.927 again. So that's what we want. We want to do the problem 2 different ways, but we do want to get the same answer. So it's still about 62 degrees. not gonna use the calculator over and over and over today. I'll set things up and then pause. And you can practice with the calculator on your own. So let's take a look at the next page. Move this down here. And we have set up and solve an equation to find the value of AB. But I changed this, and it really should say AR. And there was one other typo. I think this should say triangle RAT. Okay, so to find AR, we're going to draw in a right triangle here. So this is 15, and we'll call AR X. So in reference to A, we have the cosine of 65, because we have the adjacent and the hypotenuse. So the cosine of 65 degrees is equal to 15 over x. So that would be the adjacent over the hypotenuse. And so if you multiply what's on the diagonal and divide by what's left over, 15 divided by the cosine of 65 degrees should be x. So I'll pause and do the calculation. Okay, so my result for x is 35.49. So these are both 35.49. And this is 35.49. And then the perimeter, don't round until the end. So this is approximately here, 35.49 times 2 plus 30. But don't round until the end. And if you don't round until the end, you should get the perimeter to be to the nearest 0.01 100.99 millimeters. And then for the area, we need to figure out h. So to figure out h, we could say the tangent of 65 degrees is equal to h over 15. And so h is 15 times the tangent of 65. And when you work that out, you get 32.17. I'm going to double check that. So that is 32.17. And the area then would be, let's switch colors here. And in fact, I'm going to make this a little bit smaller. Do that over there. The area then would just be the base, or half the base, times the height. So 15 times 32.17, but again, don't round until the end. And the area should be 482.51 millimeters squared. And if we do it a second method, we could use Heron's formula here, although there'll be a lot more work here because of the decimals. I'll pause and set that. Okay, so to do Heron's formula, you have to have the semi-perimeter, and so you're going to take this value here and divide it by 2, so it's 50.49. There's a little bit, looks like there's rounding, but this is from my calculation with the calculator. So if you go back and look at the actual calculator value, this is from the 100.98 at the top. And then I have to set up Heron's formula by subtracting and taking the square root. So I'll set it up, and then you can verify it. So it's not probably the quickest method. So the area would be, although it is really quick sometimes, 50.49 times 50.49 minus 30 times 50.49 minus 35.49, and I have to shrink that up because there's more to it. And then another 50.49 minus 35.49. So there's probably going to be a little rounding error here, but I'll pause. And I just type that in, and it actually does work. It's a little slow going. Type it in, you'll see 482.51. And it's kind of hard to see on my calculator, but I did the calculations over here, and then I took the square root of it. So, all right, I think that's good for the first 2 problems. I'm going to do a few more problems, but I'll do them in separate videos, so we'll do them piece by piece.